engineer, a chemist, all patented, just adventure in himself in the automotive industry. But I gotta tell you something, every time you chat with him, it is a personal adventure. So with this, I'd like to introduce Dr. Brooks Agnew.
Thank you, Stephanie. Now this room is going to be a danger zone for the next couple of hours. So if you're timid, you might want to go to the other end. One of the things that people ask me all the time about breakthrough energy is, why do we need it? I mean, I can plug in over here anytime I want. I pay my light bill. It's not expensive. It's all regulated. Everything's good. And I say, well, you know what? When science and engineering, we have two ways of looking at things. One is the humanistic way of looking at it, which is pretty much the way all the textbooks are written, all the lectures are done, all the curricula in most of the universities is done. And it basically goes like this. I have a sink, and in the kitchen sink, I have a graduated cylinder sitting underneath the faucet, and the faucet is dripping. And let's say it's about half full. As an engineer, I can walk up to that and say, well, gee, that's dripping at the rate of about 3 drops per second. I can take my watch, I can calculate pretty much to the minute how long that graduated cylinder has been sitting there. That's humanism. The forces that are acting upon us now are the same forces that have always acted upon us, and so we can use that as a baseline to extrapolate the past and to predict the future. But there's another school of thought in engineering, and believe me, we're really familiar with it. It's called catastrophism. It means before you walked in that kitchen, somebody had the kitchen sink on, and they were filling up the graduated cylinder, shut it off, and left it dripping. It's actually only been there about 30 seconds. In fact, just as you walked in, the other person was leaving the kitchen. Now, don't you look kind of stupid? But that's the bed we've made. And so what we've done is we have discovered, by the way, I love this question. I ask engineers all the time, the last plant that we built in this little hole called Odessa, Washington. I'll show you some pictures of this project. The electrical engineers came in and they were mapping out all the conduit and they were pulling wire. And one of the engineers there, his name was Joe Harrison. I said, Joe, got a question for you. He said, yeah, what do you need? I said, what's electricity? What do you mean, what's electricity? You plug it in, the motor's turn, it's horsepower. No. What's electricity? I mean, what are we doing over there in that power plant or that dam? We're spinning up. What do we do? It's an electron factory? Where do those come from? We pump it through aluminum across here. It comes into our building and we use it. We turn it into work. But what's electricity? I've been working in this industry for 30 years and I don't have a clue. I don't know what electricity is. And we really don't. We don't know what it is. We know how it works. We can calculate it down to the milliamp, down to the electron volt. But we don't know what it is. Just food for thought. So we have this wonderful planet. This is a nighttime shot of Earth. And we've created this thing called the grid. It's easy to see at night on a clear evening when there's no clouds. It's pretty easy to see where humans have populated themselves. Human society lives along these little fibers of wire. It's controlled and it's metered by a central authority. And if you live off that grid, well, you, in times past, had to live kind of primitively, but that's getting better and better with new technology. In less than 162 years, humanity, and you can argue whether we've been here 6,000 years or 6 million years, it's moot at this point. In the last 162 years, an immeasurable amount of copper and aluminum has been stretched across the planet's human population centers and energized with electricity. We call it the grid. We live on it, we live with it. In North America, this is now controlled by a central corporation called the North American Electric Reliability Corporation. I know some engineers, they go,
who are these guys? Where did they come from? I never heard of them. They never bought our business. What gives them the authority? Well, they've actually divided up the nation into these 7 what they call PADs. These are development districts. These are areas in which the grid is self-contained, but it's also interconnected. We keep the frequency at 60.0 cycles per second across this entire grid. If it drifts just a little bit, it begins to destructively interfere with itself and breaks down. So it's very, very critical that we control the frequency. The voltage, that's a little different story. It can drift from place to place. And it's become difficult to control because humans rely upon this grid so much that it's become crucial to the survival of our society. And we seek to protect it from, well, that's the subject of my presentation. What do we protect it from? That's why these authorities have been created, because as you'll see, it continues around the planet. In this continent, we have Eurocrit. It's a research project in inventing in Europe a program that coordinates the control and the governance of the power grid in Europe. It's a little more difficult to do because instead of Mississippi and Nebraska and California, we're now talking about Germany and Switzerland and Spain, and people that speak different languages have different currencies, different rules and regulations, and the power lines stretch across country lines. So it's a little more difficult to control, but nevertheless, it's coming along. So as this grid has been created, they've created a problem with it. Since they have now centralized all the power systems into one control, into one grid, into one very sensitive spider web of power, it now has become a target, and we need to protect it. So the NERC, the National Electric Reliability Corporation, has had a series of meetings. And in these meetings, they've assigned task forces and leaders and responsible engineers, controllers, as it were, thinkers, planners. And they say, well, here are a set of what we call high-impact, low-frequency risks. They always have acronyms for them. They call it HILFs. I love acronyms. I hate acronyms, really, but I keep coming up with them. The idea is that these events don't happen very often, but when they happen, they really screw everything up. And so we need to protect ourselves against them. And so in thinking, they have built it into 3 areas of concentration. The first, which I'm going to discuss, is called pandemics. People know what a pandemic is, right? It's like a flu outbreak or spinal meningitis outbreak or something like that. What happens is the people that know how to do stuff, that know how to run the power plant, that know how to run the switchgear, they get sick and they don't show up to work, or they die. How do we turn this big generator off? I don't know. Joe's the only guy that knows how to run it, and he got the flu yesterday. I think he's gonna die. So the problem is we now have to have command and control systems that can shift from facility to facility. Now, a controller in New York can take control of a grid in Texas where everybody's got the flu, and he can turn equipment on and off. He can use the web, or he can use a Watts line or some kind of phone line to tap into the computer and take control of the power system. But this creates an opening for the next risk, which is attack. This grid is now vulnerable to cyber attacks, physical attacks. And so they have to have a coordinated team to think about what could go wrong if somebody were to create a nefarious super virus and put it into our nuclear power plants where we couldn't control our cooling valves and our reactor would overheat and shut down. Who would do such a thing? We did it. We sent it to our enemy. And turnabout's fair play, isn't it? Yeah. So for a long time we thought it was Israel that created the Stuxnet virus, but it wasn't. It was us. Actually, it was Symantec. Is that name familiar with anybody? Anybody hear of Norton antivirus? Yeah, they're the ones that wrote it. Oh, yeah, and there's a new one out called Fire. I won't even tell you what that one does. The last threat is one that we think about a lot and with which we're pretty familiar lately, and that's natural disasters. We have earthquakes and tsunamis, we have hurricanes and superstorms, and now, finally, they're starting to think about solar flares and coronal mass ejections. It's not been too long since we had one of these events happen. So here are the threats to the grid. Let's talk about pandemic first. We'll get that one out of the way. We only have an hour to do this first section. The principal vulnerability with respect to a pandemic is the loss of staff, critical to operating the electric power system. Without these personnel, people that know how to do stuff, operational issues on the system would increase as less well-trained or less experienced individuals try to fill in the gap and run things. Case in point, Chernobyl. You remember a little power plant called Chernobyl? It was a little primitive. It's what we call a carbon pile reactor. It's not like the modern reactors we have today with 15 feet of steel reinforced concrete containments around them. One of the issues that occurs with fission reactions is we try to control the way the fuel goes into criticality or gives off heat. That heat's used to boil water, to turn turbines, to make electricity. The way we slow the reaction down is we shove dense rods, usually made out of lead, into the reaction to catch the neutrons and thus lower the temperature of the reaction. Well, sometimes that reaction can get away from you and the water superheats. And when it does, it breaks apart into its components, hydrogen and oxygen, which is what we learned about yesterday as boom gas or Brown's gas. Well, this floats to the top of the containment until it forms a nice big cloud of it, and then something sparks it. And when it does, it explodes. Well, that big concrete dome that you see over the reactors is made to contain that explosion. And it will. But Chernobyl didn't have that. It just had a big concrete lid. And so when it went into thermal runaway, it blew the lid off. Now there was no way to contain anything, and now it was time to douse it with sand and water and sand and water. And of course, all the pilots died, all the firemen died, all the policemen died, all the rescue workers died, and then they got the reaction slowed down and stopped. It's still not safe to walk around Chernobyl, although it's kind of a tourist site now. I got my degree in nuclear chemistry from Tennessee Tech, and my proctor was on the NRC that went to Chernobyl to find out what happened. The truth came out. Lesser trained staff was running an emergency procedure that they were practicing. What happens is they raise the rods and let it go into sort of what we call thermal runaway. They shut off the power and let the residual steam in the system run the system that drops the rods and shuts the reaction off, which was trained for day shift. But as you know, Russia crosses 11 time zones. And so the government officials that came to observe this safety procedure didn't arrive until second shift came on. But they didn't want to stay the night in Chernobyl. We're going home. We want to see the safety procedure. Okay, no problem. Our second shift people will run the safety test. The rest is nuclear reactor history. That's what happens when lesser trained staff take things over. So we want to make sure that we can control the grid using highly trained staff, although they're in another location. And so that is a system that's going together right now. The next one is coordinated cyber attacks or physical attacks against these facilities. So the NERC is forming a task force, and I'll explain what that means in a second, to support and promote the development of scenario-based analysis tools to include robust system modeling, scenarios of potential structured attacks to assess system response capability. How do we do that? Well, we bring along the good old Department of Homeland Security, and the Department of Defense. So around your local power stations, here in Europe and also in the US, you're going to start to see drills being run. You're going to see military vehicles show up. You're going to see mock disasters going on. They're already going on in your towns all over America right now on small levels, but you're going to see more and more of it. The authorities shall support R&D of protection and what are called mitigation tools. Let your imagination run for a while what that means. How about monitoring all your emails, all your cell phone communications, all your purchases of components, electronic components, fertilizer, fuel usage, travel records. All of those things are mitigation tools as far as the Department of Homeland Security is. These tools should include enhanced forensic and cyber network monitoring capabilities. One of my motorcycle buddies, his name is Shane Cruz, works at Oak Ridge, where I did my postgraduate work. And in those days, I had, I think, a 1 meg internet connection, which was just smoking compared to dial-up. So we're out riding one day, and we stop, and we're talking about internet. And I say, so Shane, how fast is your internet connection? I was really proud of my 1 meg. He says, 3 gig. I said, what? 3 gigabytes is your internet connection? Yes. I said, why? Why do you need an internet connection that fast? I like changes screens before you hit enter. He said, because we monitor emails. We monitor the net traffic for nefarious activities. If anybody visits a site in the Middle East, they immediately go on a watch list. All of their emails, their communication, code words, patterns, purchase patterns, sites that they visit, all this stuff is then cataloged and they're profiled, and then we move on them. In London, they've done this with cameras. If a bomb goes off in London, they will go back and look at the camera records, and they'll trace everyone that went in that building all the way back to their apartment, and within 1 hour, they're making an arrest. It's become so effective that terrorism in London's almost preempted. They now know how to pattern people and profile people by the places that they visit, the things that they buy, and they can watch them that closely. The internet's getting that way.
Cameras from the street or cameras from satellite?
Both. The satellite cameras are pretty good, but the street cameras are much better. They can take facial features. They can even check the temperature of your body. So they can profile you if you're anxious or upset or emotional. They can pick this up by the colors that they see in the infrared. And if you pull up to almost any intersection now, you'll see the red light camera, and then you'll see 4 or 5 other cameras. They're looking down inside your car. If they take a photograph, they have your car, your license, your face, and everything. And these are 10 megabyte cameras. So they can blow it up and go right down into, what you've got in your pocket, just about. And these surveillance cameras are everywhere. How many people have seen someone pulled over on the freeway lately, speeding? Did you see them actually followed by a cop car? The trooper comes on the freeway, catches up with the car, and pulls it over. They're watching you drive on the freeway. There's no speeding looking up ahead. Is there a cop up there? Forget about it. And now there's permission to fly 30,000 drones over the United States. And guess who's first in line? Sheriffs and police departments, because they're the new revenuers. Let's talk about this physical attacks. Not really a huge threat yet, but they're also forming a task force to support and promote the development of these scenario-based tools. And that means you're going to start seeing this around your town. This is a very recent picture. It was taken last month. The other one is the coordinated cyber attacks. We've all heard about this. China, Iran, other countries, Pakistan, and they're doing it not just to us, but to other countries too. They're practicing all the time with ways to crack through the system and take control of utilities. And we're doing the same thing to them. We're also watching all the shipping containers that are moving, and it's difficult to do. You see this ship in the lower right-hand corner. There's 1,000 of these a month that come into the United States. Trains hauling shipping containers all across the country, and those seals go on at the point of origin, and they don't come off until it gets to the point of destination. You can put anything in there, and they usually do, and we cannot monitor all of them. We can sample them, but we can't check all of them. We don't have the capability yet. The point is that we've gotten to a point now where we're getting so good at this that we can almost predict when things are going to happen, and we can stop them before they do, except for this one. This one, major natural disasters like earthquakes, tsunamis, large hurricanes, geomagnetic disturbances caused by solar weather. This is a little bit different. As control freaky as we try to get, we try to control that sun. We're not doing a very good job of it. The NERC has learned through high-impact, low-frequency solar storms that the grid is sensitive to extra energy being fed into the system from external sources. Isn't that what breakthrough energy is? We're tapping into this extra energy in the system and we're making it useful. But when the sun has a hiccup or decides to throw up or have an allergic reaction, we're only 93 million miles away. That's about 73 hours at 1,000 kilometers a second. Millions of tera-electron volts can enter the grid from a solar flare or coronal mass ejection. It happened already. Power goes out in millions of miles of aluminum and copper suspended across the surface of our planet. And it acts like a giant antenna, so these wires can also receive energy on the secondary side. So we're not talking about this power plant. This is a typical nuclear power plant, flowing energy out to the grid in a very controlled, very precise, frequency-controlled, voltage-controlled manner. It goes to these, which are the giant step-down transformers at the substations. You've seen them when you drive around. These particular ones step down from 161,000 volts to 13,800 volts. From there, transformers pick it up and step it down to 4160. From there, 880, 440, 220, and then into your home. That's the way the grid works. We constantly step down the voltage, stepping up the amperage so that you can use it in your home. Goes along these high tension lines that you see all over the countryside. But this is what one of those transformers looks like on the inside. We have a primary side with a lot of coils, and we have a secondary side with a lesser number of coils. Now, these particular transformers are what we call auto-tap transformers. So if the primary side voltage drifts up and down, the transformer can switch taps inside the transformer to keep the secondary side voltage at your house from drifting up and down more than about 10%. We try to keep it within plus or minus 5%. This is how it steps down. 161,000 volts, 13,008, 4160, 440, 220. Pretty simple, pretty easy math. Now, that step-down transformer, because the power is coming from the plant to the house, is pretty easy to figure out. But what if the step-down transformer becomes a step-up transformer going the other way? Let's suppose we get 10 million volts coming in from the sun, going on to the secondary side, all that aluminum and copper you see out there in your neighborhoods, and it goes back through the transformer and steps up to the primary line going to the power plant. Now you have about 7.3 billion volts going back to the power plant, and now you see the problem. The problem is the core of these transformers melts down. And when that happens, and it has happened, this is the 1859 Carrington event. This is the actual voltage spike that they recorded. This is one of the paper ink records that they have from that event. As you can see, nobody in 1859 expected a solar flare to do this. And we're talking about telegraph wire, DC, where just tapping dots and dashes along a wire with amplifiers every now and then because DC has such terrible losses along copper wire. The wires picked up the voltage, ran it back into the telegraph offices, caught them on fire, electrocuted people, and made this printout. That's before we were an electric society. Then, the Northeast American grid collapsed in 1989, almost 100 years later. The storm led to the collapse of the Hydro-Quebec system in the early morning hours of March 13th, 1989. Here's the time sequence. This is how little warning they had. At 2:44 a.m., operations on the Hydro-Quebec power grid were normal. At that time, a large impulse in the Earth's geomagnetic field erupted along the U.S.-Canadian border. This started a chain of power system disturbance events that only 92 seconds later resulted in a collapse of the Quebec interconnections. Less than 2 minutes. We had no warning whatsoever. No satellites were up there to guide us or protect us. 1989 was a pretty modern time, and we weren't ready. Case number 3, and I think we were just talking about this morning at breakfast. In Yuma, Arizona, they went to make a routine switchgear change. They didn't do it routinely. Somebody did it wrong. Yuma, Arizona made a mistake. That mistake cascaded through the grid and shut San Diego down. It wasn't down for a couple of hours. They had power problems for 3 days. Big problem because El Toro Marine Base is located there and they were dark for 8 hours. In today's battlefield, and I've made this presentation to the Department of Defense, we don't have a tactical side and a non-tactical side anymore. We have people in Nevada flying UAVs in Afghanistan by wire. They're flying them by internet. The non-tactical side is now the tactical side. And when you have a base go dark, it's just like losing support in the battlefield. Unacceptable. This happened, what was it?
Yeah, it was last year.
Last year. We're a pretty modern society. We got satellites. We have the SDO. We have SOHO up there. We know when these things are coming. Still, one switchgear mistake, 2,500 miles away, and San Diego goes dark. So, what is the solution? How do we solve this? How much time do we have? All the time I need. I like it. We're time travelers here. We have this grid. We generate the electricity. We put it on the system. We have centralized all the control and command. We've got Department of Homeland Security fully in control of everything. Everything's under control. We have a team of experts fully trained in your area. If the Russians were to attack the United States on the coast of Florida wearing rubber gum boots, it's already been figured out. Team of experts already has a contingency plan in place. Nothing to worry about. Go back to the mall. But what is a solution? What can we as entrepreneurs in this energy business do to capitalize on this need? This tremendous oversight of the juggernaut energy giant that thinks they have all the answers. They came up with 3 threats: pandemic, attacks from cyber and physical attacks, and these natural disasters, but there's a 4th threat they forgot about: competition. Suppose that we back up El Toro Marine Base with a system of high-tech batteries or other storage devices. Some of that technology is sitting in this room right now. And suppose that instead of this very expensive high-tech storage device sitting in a room somewhere like a giant insurance policy that we keep paying on and we think we will never use, suppose we make the storage device mobile. We drive it around. We put 40 kilowatts under the bed of a truck or a bus or a tug or a boat of some kind, and we're using it every day. We're driving it around. And suppose that we use some kind of renewable energy to supply power to that mobile device, like sunlight or like vacuum fluctuations, if we have a way to convert that into electricity and pump it back into this vehicle. Now we have a useful system by which we can support that weakness in the grid. And in my second hour, my presentation, we're going to talk about the business case for making this happen. The question is, if these big transformers melt down, how fast can we get things electrified again after this happens? How much inventory of these $500,000 transformers do you think we have inside the United States or Europe? Correct. The answer is zero. Nothing. When's the last time you tried to order an electric motor over 5 horsepower? Did they have one on the shelf for you? Did Reliance Electric say, no problem, Joel, we'll ship one right over to you? 6 weeks. What do you mean 6 weeks? Can't you just get one off the shelf? Sorry, no inventory. We only build to order. These take about 6 months to build. There's a lot of winding that goes in, a lot of regulation that goes, a lot of testing that goes into these. And by the way, the plants that make these transformers, they run on electricity. It gets a little harder when you have to rub 2 sticks together to make fire, to build a $500,000 transformer. I would say we're probably looking at about 2 years, and I say that by authority because I just did a contract for Cooper Power Systems last year. And they make this dandy little 40,000 kVA step-down transformer. It takes about 6 months to make them. They have 0 of them in the yard. They make them to order. The little pole mount transformers, about 2 weeks supply. Nationwide, 2 weeks supply of the pole transformers. Less than that of the pad mount transformers. That's the little green one that sits in your yard that runs 2 or 3 houses. Little 14 kV system. The Northeast Power Coordinating Council, the NPCC, contracted with Solar Terrestrial Dispatch, private company, for a solar notification and communication system used by the 5 reliability coordinators in the region, called the Geomagnetic Storm Mitigation System, another acronym, GSMS. An active communications software package installed on the system operator's console provides each of the NPCC reliability coordinators with geomagnetic storm alerts. You're only going to get 73 hours, tops, or less, maybe 48 hours notice. Upon receipt of a geomagnetic storm alert of KP6 or higher, the GSMS simultaneously provides visual and or audible alarms. Sounds something like Anybody see the China syndrome? That's kind of what it's like. A main screen providing the system operator with all the information currently known about possible solar activity, including terrorist films that might be produced in Florida. A dialog box permitting instantaneous communication among all NPCC reliability coordinators of any observed solar magnetic phenomenon. Wonderful. We have a notification system. We now have 48 hours before, oh shit, happens. So how do you protect that from happening? Well, as a decently trained power distribution engineer, I would say the best way to do that would be to go to the substation and throw open the bus bars. You ever done that? That is a rip. You grab a big fiberglass pole and you physically reach up and grab the aluminum bus bar, which is about this big around, and you open it like a giant knife switch. Well, when you do, it's like a big lightning bolt that follows that until it gets far enough away the voltage can't make the jump, and you're dark. That's it. The transformer is now disconnected, and so are you. Wait a minute, I have a screen, and I get these alerts, and they come to me, and I have a series of functions that I can press on this high-tech Siemens touchscreen that I have, and I can alert people. Well, I'm sorry, Mr. Jones, but your lights are out. We threw the the bus bar at the substation. You now have no power in your building. Your computer doesn't work. Your phones don't work. Your cell phone towers are down. Would you happen to have some carrier pigeons around? 2 cans and a string, maybe. The entire communication and command system relies upon electricity they don't have, because the main substations are trying to protect those transformers. I can prove it. I know what happens. 73 hours, that's all you got. So the strategy is to centralize the control. Bring it all in-house. Let us watch over everything for you. We're watching out for you, to steal a line, so as to protect it from these 3 forms of threats. So how do you think we'll do? Is the strategy effective? That's what we always ask in the quality business. Is this effective? Is this going to work? Let's see. 2007, Hurricane Katrina. That's a nice photograph of it, by the way. Truly a disaster. I was 90 miles off the Gulf Coast. A year after this happened, I was actually working in Fort Worth when it hit. It was devastating. Winds like unbelievable, and they went on and on and on, band after band, and within hours, the scavenging began. Everybody knew the storm was coming, but nobody prepared. We had way more than 73 hours. We had a week just about to track this storm. Anybody that watched TV knew it was coming. And yet within hours, the scavenging began. Locals pulled together. Looters will be shot. Yeah, we don't do that so well anymore. And of course, the government came out to help everybody. We'll make sure everything's under control. Okay, we didn't do so well on Katrina. We had government problems, we had trouble getting the Red Cross in there, and the cookies and cocoa were a little late coming. Fortunately, it happened in September, so it wasn't too cold. Let's do a reset. Let's try it again. Another area of the country, much more well-performed, much more well-protected, much more well-connected. 2012, boy, that's this year. Superstorm Sandy. Now, we got way more than a week this time. We saw this thing way out in the middle of the Caribbean. We saw it go across Cuba, up the coast. We knew the size of the storm swell. We knew the wind speeds. We knew it wasn't going to be a true hurricane, so we called it a superstorm, which it really wasn't a superstorm. It was kind of a mild storm, 80 to 100 mile an hour winds. If the winds had gone up to 180, like they were in Katrina, you would have had another problem. We would have started to pull stratospheric air down to the surface, and the temperature would have gotten down to about minus 45 degrees. Serious problem. That's a superstorm. If it had happened a month later, serious problem. So how did we do? Well, let's see. How did the system respond? Lights out. This time, we threw the bus bars. This time, we shut the big transformers off ahead of time, before the storm swell came. We shut the subways down to prevent permanent damage. Within hours, the scavenging began. It's still going on. They're still short of gas. Still see people every single day. Where's my cookies and cocoa? Where's my bottled water? Who's going to take care of me? And of course, the government showed up, ready to help. FEMA was there. Red Cross was there with blankets the size of pillowcases. And they took care of everybody, right? No. What, 40,000 people out of homes, estimate? No gas. Electricity's coming back day by day. Well, that is to say, if you're unionized. Locals pull together, yes, no? I don't know. It's not working very well, maybe. But government showed up. You know, I would love to be just like Obama's wristwatch, just to know, 5 minutes, this is good. What was being said right here? I'm not going to say anything. You can put it in your mind and figure it out. Lights out. Space shot. You remember our grid we could see from space? This is what it looked like before the storm hit. authorities took over and they shut down the utility district. And that's what it looks like. The city that never sleeps, slept.
My lights went out in the middle of New York City.
So here we are, 2012, beginning the solar maximum. Oh, we've been watching for it. The Maya have been watching for it. The Egyptians have been watching for it. Every ancient civilization talked about this day at this time, this alignment between the sun, the galactic plane, and Earth. And we're only beginning to see. We're experiencing it right now. Not global warming per se, but climate change. Winters are worse and summers are worse. We broke, 7,000 heat records a few months ago? Now we're going to have record snows. Nick's from Alaska. They had record snows last year in Alaska. They're used to snow in Alaska. But 100-mile-an-hour winds, 18-foot snow drifts in one day. These is extremities that we're seeing, not just in the northern hemisphere, also in the southern hemisphere.
Just a few days ago, we had the most severe weather there for, people in remembrance.
Yeah, exactly. So is centralizing the grid really a smart idea? Is putting all this command and control in one place, putting smart meters on your homes so that they know when your power demand is, so they know exactly how much coal to burn, exactly how much steam to generate with that nuclear power plant. It's smart on their side. They can control the inputs that they spend money on, and they can bill you every 2 minutes for the amount of electricity that you're using. Your appliances are about to go up in price too. I did a contract last year for Census. They're now coming to Europe. They make the smart meters, not just for your house, for your washer and dryer, for your water heater, for your heat pump. That means the utility company can look at the load and shut your heat pump off. They can turn off your water heater. They can turn off your washer and dryer. They can turn off your stove from the power company to control the load on the grid. That's central authority. That's central control. So I would say, and we'll cover this right after the break, consider a decentralized, low-voltage energy supply strategy. Self-sustaining homes. Self-sustaining homes that have style and the things that you need for basic use. Self-sustaining buildings, solar power, wind power, battery storage, cisterns that can store a few days of clean water for, if not for drinking, for flushing toilets. Stuff that keeps cholera from building up when you have a natural disaster. How about self-sustaining vehicles that can charge themselves in the sunlight? So after the break, we'll cover the business case for breakthrough energy. Bring your friends. Thank you. Thank you. That's the good stuff. All right, let's talk about the business case for breakthrough energy. Isn't that the reason why we have these conferences and fly all over the world and try to convince people, persuade people to our way of thinking? That's what I wanted to hear, absolutely. The business case for breakthrough energy. This is where, like we say in the automotive business, where the rubber meets the road. All right, when we begin manufacturing, this is a 10,000-foot view of the process. The first thing we come up with is the concept. We do this on usually on cocktail napkins with good scotch and a cigar, or on a paper bag or on a computer program, but we come up with the concept. We draw it, we design it, we dream about it, we discuss it with our peers, and we try to come up with a good idea. We're still coming in. Welcome back. The next thing that we do is we develop a prototype. We sometimes we file a provisional patent right in between here, so that we have a place marker for our ideas. And then we develop this prototype, if it's a machine or some kind of design or some kind of application. And then we take the prototype and we get with our materials and applications people and we go into manufacturing. We build the product, we package it, and then we do the marketing. We take it to the market and it either sells or it ends up in big lots. Big lots are where good ideas that were poorly marketed go to sell. In breakthrough energy, we've kind of done it the other way around. We've started with marketing right away. We come up with the concept, we go right into marketing. And then we shoot off in every different direction possible. We go to traction, electric power, combustion, heat, conservation, gravity manipulation. We just throw it all up against the wall and see what will stick. And sometimes it sticks and it stinks. And sometimes it works and it doesn't go anywhere. It just sits on the wall, covers up another stain on the wall. So when you have limited resources, how many people in this room have limited resources? I'm in good company, all right. We have limited resources. We have to do it this way. We have to focus. We've got to, you know how inventors are, right? They're single-minded, focused like a laser beam, right? No. They're more like a floodlight in a parking lot. They love to ask this question. Wouldn't it be neat if we could do this? And off they go. Or we could do this. And I had this other idea. And if you don't like that, it comes in 4 different colors, that other idea. The other one. No, not that one, the other one. You get the idea. We need to learn to focus as an industry. And in manufacturing, we call that niche markets. Niche markets are the ultimate point of focus. And the question is, which niche market are you going to approach? Well, that's a question that only you can ask as the inventor. Or if you invent a technology, you can get with good application engineers, and they can think of ways to apply that technology, whether it's in a cell phone, a laptop, an automobile, an airplane, a spacecraft, a boat, or a toy. It can be applied in a way that the niche can become lucrative. So the point is that there is a business case for an electric motor, but electric motors that bring outside energy into the equation don't exist yet. Or do they? How big are they? I mean, do I have a 5 horsepower motor that I wear on a backpack that runs my wristwatch? Not very practical. You got to find a way to get these things in a package that can be useful. Yesterday, we saw a video, which I'm sure many of us in this room have seen, of the John Searle effect, right? We've seen the magnets going around and around on the inside corral of the coils going around. Awesome demonstration. What can it be used for? How can you fit that system, which I don't know what horsepower that motor was. I'd say it's probably about 1/16 horsepower. But I've got 1/16 horsepower motors the size of this mouse that can ride a motorcycle. So we've got to think about practicality. We talk about permanent magnet motors. Wonderful idea. Just you're limited in power by the magnet itself. The magnet is an integral part of that process, and that's your limiting factor. The more powerful the magnet, the more powerful the motor. Who controls the most powerful magnets in the world? Exactly right. China. Rare earth metals used in magnets. So concept, remember niche market. Product design. If you have a motor, figure out where you can hide the motor. If you're in breakthrough energy, what are the words we love to use? Over unity is a good word. We love to use that word. Guess what the industry hates to hear? Over unity. How about 0-point energy? How many times have we used that one? That's like the drunk at the party anymore. We don't want to hear that word in industry. How about replacing it with words that function in our industry? Code words, blanket words like ultra high efficiency. You can plug it in if you want or not. What? Well, go ahead, plug it in. But if you forget to plug it in one day and it still runs, don't blame me. You got to figure out a way to hide the technology in things that will work. For instance, I'm in the electric vehicle business, and what's under the hood, what's under the bed of the truck is hidden. We paint our battery boxes black. I mean, anybody with half a brain and one eye from 50 feet away can see our battery boxes. But I have people walk up to the truck every day and say, "Where are the batteries?" They don't see it because the truck is yellow and the battery boxes are black. It's hidden. We hide the batteries. I tell them it's in the glove box. So if I had a generator underneath the bed of that truck that was sitting there quietly recharging those batteries without it being plugged in, do you think I'm going to tell anybody? No, it's hidden. That's a special adapter. It takes all the vocal vibrations in the room and converts it into electricity and pumps it back into the batteries. So the more you talk, the faster the batteries will charge up. Yes? Yeah, that's good technology. How does that work? I have no clue. We buy it from some company in Nebraska. We just plug it in. But if you open the box, it'll stop working, so don't do that. Just leave it alone. There is a way to do this by getting the technology into the market. I can tell you that the inventor, after he cashes a few of those $10,000 a month checks, doesn't give a rat's behind if it's zero-point energy. He doesn't care if it's over unity, not a bit, because he's making money. He's making a good living, which is something I don't think anybody in this room is doing in this industry right now. We can go out and we can keep saying what you want to say, and you'll keep saying it. 50 years from now, you'll be saying the same thing, and you'll be doing the same thing you're doing now. I'm making a business case here for breakthrough energy. If you have a generator, figure out where you can hide that charger. Hide it in something where it will work. Put it in a cell phone that will last for 6 days on a battery, something like that. Develop the prototype. This is the chasm for this industry. And by I mean a prototype, I don't mean a prototype of the generator. I mean the number one cause of disease in the world is lack of refrigeration. You didn't know that. A lot of people don't know that. Keeping food cold or medicine cold is a big shortfall in third world countries. I heard somebody from the Dominican Republic yesterday was talking about for 50 years, they have been going without a single 24-hour day with 24 hours of electricity. Now, they've gotten used to it, but it's not the same hours every day that the power goes down. It's not like between 4 and 8 p.m. Hey, you better close that fridge by 4 p.m. because the power is going to go out for about 4 hours. It happens all different hours. It's all discombobulated. That's a great word. I like that word. But it's also that way in other countries. India, Mexico, Pakistan, we have power interruption. In a lot of places in India, they don't have reliable electricity because somebody keeps tripping over the extension cord from the other town where they're bringing the power in. But if you had a refrigerator that you could set in the middle of nowhere that would stay at 40 degrees all the time without plugging it in, without changing batteries, you'd have a product that you could sell hundreds of millions of them all around the world. Now, do you make refrigerators? No, probably not. But you make that variable speed compressor that goes on the inside that runs on that 0-point energy that keeps this thing cold. Or has a solar panel on top, or it has some kind of antenna that picks up the vacuum fluctuations in the back of the fridge and makes it stay cold. You know how many horsepower you need to make this run? About 1/8 of a horsepower to keep this cold. I've heard all kinds of claims. I've heard 10 kilowatts out of a package the size of a pack of cigarettes. Did it ever deliver? No. If you could deliver me 3 kilowatts in a box smaller than that of a microwave oven, I can make you a billionaire. This truck that we build, we use solar panels because it's free energy. You drive it around, it puts 150 watts in the batteries. Is that enough to drive on? No. But an amazing thing happens to lithium-ion batteries when you supply a little bit of power to them all the time. I'm not going to tell you what it is, but it's amazing. No, it's not enough to keep the batteries recharged. It'll take you about 5 days to charge that truck up by its sunlight with one panel. But trust me, it's worth it. This truck, if you are only driving 12 to 15 miles a day, which is a little bit more than you get out of a Prius battery, you never have to plug it in, ever. Concept. Oh, wait a minute. Market, prototype, manufacture, market. Yeah, that's where we are in the breakthrough energy business. We come up with the concept and we go right to marketing. Let's go sell this thing. Let's raise some money. And then we'll build a prototype. Well, that's where the break is right there in this industry. Every single rank and file in breakthrough energy gets stuck right there. So what are we going to do about it? Are we going to keep going and beating up the private investors, the lenders, the mom and pops out there to give us $30,000, $40,000 so we can buy another bearing, or we can buy another piece of plexiglass, or we can buy another piece of high-grade copper or palladium or whatever it is we're going to use as a catalyst? No. We have a model that's broken in this industry. We need something different. So if we're going to make these prototypes, now some of us have jobs where we can take some of our money and pocket it away, and we can go to a shop and we can build our prototype. In a couple of years, we'll have it done. Not everybody has that luxury. Most of these inventors, at least the ones that I know, are practically unemployable. They're like savants. They're brilliant in one field, and they're socially retarded. I'm just using that as an example. I'm not using anybody specific, okay, Stuart or Sterling. The idea is that we have a system that doesn't seem to be working for our industry. We have the holy grail for the human race. We can not only save the third world, we can save the first world from becoming the third world. Because we have an idea, as you saw in this last hour presentation. They're centralizing the grid just fine. And they're moving forward with it, and they're going to spend about $200 billion doing it. And we're out here picking crumbs with the sparrows. Our road looks like this. This is Mount Everest. In fact, that's why we call our truck the Everest. That's the very reason. Because we had to climb it to build that truck. That's why it's called the Everest. It's not because it's big. It's not because it could climb the Everest. It's because that's what it took to build this truck. We need to have a better way. We took this car that we built 4 years ago. This is the same technology, only now it's in the truck. This video's kind of poor.
Do it one more time. Okay.
Let's do it this way. Some people say electric cars don't have any torque or power. I say, get serious.
All right, the video's really bad. But I just laid 55 feet of rubber in a truck, in a car that the gas version never could spin a tire on a rainy day. And the truck can just about do the same thing. In fact, it does an 18-second quarter mile. So how do you do this? Well, you do it through a lot of back-breaking work. That prototype, getting to that prototype stage, finding the golden opportunity and making it work. We found some technology to make biodiesel out of canola oil. Great company, totally disconnected, couldn't raise money and couldn't finish their idea. But it was a good concept. So we went to Washington State. They had an Energy Freedom Fund, $7.5 million, sitting there unused. Been sitting there for a year, as was this old building. This building had been sitting since 1964, empty. As you can see, it's in premium condition. But anybody that knows anything about metal buildings knows that normally we put these purlins about 4 feet apart. These are 12 inches apart. This building, they used to fill with wheat from the concrete floor all the way to the roof. It was called a flat house. That's why these 1.25-inch steel rods are connected to the floor to keep the walls from blowing out when they fill this thing with wheat. Well, when they came up with the CRC program, paying farmers not to farm, they stopped filling this building with wheat. And so they just used it to hold motorhomes and boats, during the winter time. And it was unused. So the co-ops, one co-op had 10,000 farmers, another one had about 7,500 farmers. They came to us and said, look, we like the idea of the biodiesel plant. We have this old building, which we'll deed to the process. And we have this $7.5 million Energy Freedom Fund. And we want you to finish the design and convert this building and build it. So this was one of my consulting jobs, and Robin ran the labor crews to do this. You'll see one of them here in a second. Well, the first thing that we did is we drew out a plan. How are we going to put this together? What are we going to take apart? How are we going to finish the design? And then we proceeded to cut this building apart. All those steel rods, all the connecting bolts of the floor had to be removed. The floor had to painstakingly be cleaned. It took weeks to get it clean. We finally got the floor cleaned. We hung some lights. It didn't even have electricity in this building. We hired a crew to paint the floors, and it looked like this 16 days later. As you can see, the job trailer is set up. The last paint is going on the floor, and now we have a building. We're going to begin building this process. By the way, this piece right over here is the only piece of technology that was even 1/4 of the way finished. The inventor, brilliant, but discombobulated, couldn't pull the plan together, couldn't put the pieces together. The reason I'm showing you this is this process needs to be done throughout the breakthrough energy business. This is what it looked like on the outside of this building, and this is what it looked like on the inside of this building 3 months later. Completely insulated. Yeah, it's 10 below outside, but it's 55 inside. And we started building this plant, and we finished it. And this is my team. All the engineers, all the people, all the local authorities. Here are all the team members that we pulled together and declared energy independence. And it was successful. And Senator Maria Cantwell was happy that we finished it inside the budget of $7.5 million. By the way, 55 companies had been turned down before we showed up to do this. And the next biodiesel plant, other than us and another state, cost almost $60 million to build. This one worked. It produces 100% pure biodiesel continuously manufactured 24 hours a day. And I use this as an example because this is what we have to do in the breakthrough energy business. We got to learn to get across this chasm from concept to prototype. We were lucky. I always hate when people say that, oh, you were lucky you got that thing up there. No, we were in the right place at the right time, but that was opportunity meeting preparation. We built this bridge, and we made it across the chasm. This is how we get from here to there. This is the business case for breakthrough energy. While they are centralizing the grid and spending $200 billion to create this command and control system globally to protect the grid from these three major threats: pandemic, physical and cyber attacks, and natural disasters, including solar flares, I propose creating a global energy freedom fund using a multinational shareholding body formed from 9 engineers that manage a revolving global fund of $1 billion. This can be 9 engineering groups from 9 participating countries. Here's their plan. The NERC, that's the National Electrical Reliability Corporation, sprung up out of nowhere, by the way, had instant funding from the government and taxpayers, and is coordinating this entire activity between the U.S. FERC, that's a Federal Energy Reliable Corporation, the Department of Energy, all well-intentioned engineers, I'm sure, not, the Department of Homeland Security, NOAA, and NASA. By the way, those are all government agencies, all taxpayer-funded, and not just U.S. taxpayers, also international taxpayers, and appropriate government authorities in Canada, together with subject matter experts, should work together to recommend the development of advanced methods to ensure system operators are given region-specific, timely, and accurate information regarding the expected duration, intensity, and geographic footprint of impending geomagnetic disturbances. Focus should be given to both extreme events and long-duration, low-intensity storms. I don't read a darn thing in there about decentralizing the grid on a low voltage level, protecting the consumer and businesses from this same threat. I only see something put in place to protect them. So, the NERC has centralized the grid, and they're well about it, and they're about to spend $200 billion to attempt to protect it from a variety of threats which we have talked about over the last couple of hours. That threat would not exist if the grid was decentralized by integrating it with sustainable, non-centralized, high-efficiency, ultra-high efficiency technologies. Agreed? I agree too. So the Global Energy Freedom Fund, I propose that we internationally write up a mandate or write up a proposal to these governments that 0.5% of the budget for centralizing the grid shall be allocated to the GEFF for the purpose of prototype and manufacturing proliferation of technologies to decentralize the grid. Are we going to compete with the grid? No way. We're not generating megawatts of energy. We're not going to spin the meters backwards, at least not in the near future. But we are going to protect ourselves from the scavenging that we have seen happen in 1989, in 2007, and now this year in 2012. We're not doing a good job of protecting we the people in the United States, in Europe, anywhere, from any kind of disaster. Are we? So when a solar flare comes in, like we saw in 1859 or 1989, are we going to be ready? No. They might be able to disconnect the transformers, as we saw in New York. It went dark. It went to sleep. Yes, they saved a lot of the secondary grid, but the people suffered because they had no way of getting one single glass of clean drinking water. And we're not a third world country, and neither are you. So this proposal is a multinational shareholding body formed from 9 engineers or 9 engineering companies, one from each benefit country, that manage a revolving global fund of $1 billion. Joel, what could the breakthrough energy movement do with $1 billion to get technology through the prototype stage and into manufacturing?
You could fund 100 technologies at $10 million a year ongoing, and you'd start slamming some into the public domain.
Exactly right. It gets us that bridge across the chasm. If they're going to spend $200 billion, give us 0.5% of it, and hopefully we manage it correctly without corruption, because that's the key right there.
The Pentagon eats that much in pizza a year.
Yeah. And that's just the 3-topping pizza. The GSA, the General Services Administration of our government, produces nothing. The only thing they do is manage a phone book. They manage a Rolodex of companies that sell to the U.S. government. That's it. They have 12,500 employees. 12,500 employees to run eBay for government. And guess what they get to decide? Who gets to list on eBay and who doesn't? And that's the way the system works. It's corrupt from top to bottom. If we could build this or an organization like this, I don't care if you call it the Mickey Mouse Club, as long as we get the same or a fraction of the capital that they're getting to centralize the grid, to decentralize the grid by creating these end-use technologies, I think we can prevent ourselves from rubbing 2 sticks together to make fire someday. These are the 9 countries. I just thought of these. You could change it. You'll notice there are a couple countries that aren't there. You may be represented in this room. I don't know. the United States, Mexico, Eastern Europe, and Western Europe, you have completely different energy needs. Australia, South Africa, Japan, India, and a member-approved Asian country. I don't know who that would be, Taiwan or I was going to mention China, but I don't think anybody in this room has had a good experience having things built there. This is the idea. The Global Energy Freedom Fund, designated to be a vetting body to approve loans to needy technology providers. I guess that would be companies worth less than $100 million. Seems like every time we have a grant program in the United States, all the money goes to global international corporations. Small business doesn't get a dime. I mean, correct me if I'm wrong, I'm kind of scratching my head here, but don't global international multi-billion-dollar corporations have their own R&D funds? What do they need our grants for? What do they need our taxpayer funds for? Why do we have to keep bailing their failed ideas out of the fire? Why can't we send the grants to small business only?
It's called campaign contribution.
Yeah, there you go.
I hope this works without interest.
No. As I said, it's a revolving account. So as each of the technologies becomes successful, it pays the grant back. It pays the loan back. So it can be used by the next technology and the next and the next. The organization could take the money and put it in interest-bearing accounts and earn interest. But if it's going to stay in business, if they're going to entrust us with $1 billion, which would last about through lunch at the Pentagon, we need to make this perpetual because they're never going to do it again. If these technologies are commercial, then by gosh, they're commercial. If they're not, if it's a black hole that never produces a prototype, it's going to go broke and the technology is going to disappear forever. And we're seeing it right before our eyes. The list is right on the tip of my tongue. How about Solar One? 10 years the guy worked to launch a solar energy company. Oh, he launched it all right. Took in $700 and some odd million in U.S. taxpayer grant money, put $450 million in his personal pocket and bankrupted his company. How about A123? How about Interdel? How about Solyndra? Same story over and over and over again. Hundreds of millions of dollars going in the company, right into the pockets of the founders and original investors, and right out the back door until all the employees are fired. If that happens to the Global Energy Freedom Fund or some acronym that's like it, it's over. It's done. You get one shot. That's why, up until now, for the last 10,000 years, it's been done this way. The inventor puts his own money and convinces his friends and families to invest in his crazy ideas. That gets the idea to market. That's not going to work now. We have 73 hours of warning, and it's not doing it for us. It's not cutting it. We're losing regions of the civilized world every single time a natural disaster happens, and they're happening more and more often. And all it takes is something a little bit more regional than regional, and we've got a real problem on our hands. We have the solution. We have the ideas. We have the motivation. All we need is to be able to jump that chasm. We need that bridge. We need good diplomats, good thinkers, good consultants to put together this proposal, and let's get it before the UN. How about that? The General Assembly of the UN. Is that a good body to go to? No? All right, well, whatever. There's got to be a way to diplomatically make this proposal and get a piece of that money that's being set aside. It might be an exercise in futility, but I don't think there's a single person in this room that believes that. Let's do it. Concept to prototype, funded, to manufacturing, funded, and to market. Let's make this happen. 99.5% of the National Electrical Reliability Corporation and the Eurocrit funding will be used to centralize the command and control of the global power grid. 0.5% of the national blah, blah, blah will be used to decentralize the global power grid with sustainable technologies. That's my presentation. My name is Brooks Agnew. Thank you so much for your time and attention. Yeah,
People will ask questions to Brooke. Go ahead.
yeah.
I only don't think we can facilitate that with a microphone, so speak up.
Before the questions, I have 16 books that I brought with me from the U.S. My back cannot take hauling them back to the U.S. 10 euros a piece and I'll autograph them. You'll like them. All right, questions. Yes.
Hello. Oh, we got sound.
Question up here.
The truck you're making. Uno momento, please. What is the price for that?
The Everest retails for $28,500 before grants, rebates, whatever. It costs about $300 a year to drive.
Okay. And the range?
It will go approximately 100 miles on a charge on flat level ground. If you're going to be climbing mountains, hauling a boat, hauling 1,000 pounds, it's going to be less than that. But it's a workable distance. It has an onboard charger. You can plug it into 120, 220, or the sidewalk chargers, or just leave it in the sunlight.
And what is the present production capacity?
We can produce 600 vehicles a month right now with our plant in Michigan. If the demand's higher than that, we can ramp that up to 6,000 vehicles a month with about 1.5 years of preparation.
Okay, thank you.
Right here?
Are we going to have a group to talk about this fund afterwards?
Yes, there'll be scotch and cigars. We'll talk about it. I am not a financial guy. I'm an engineer. I'm a consultant. I consult with Fortune 500 companies to make them more profitable and build a better quality product. I'm proposing the idea, and I'd be happy to work with anybody who wants to take that ball and run with it. I mean, Sterling's got an organization Joel works with, and there are other organizations in here that have good ideas and their heart's in it. They've been in it a long time. They've flown uncountable miles. They've seen all kinds of wannabes in technology, and maybe they should be involved too. But there's got to be a way to pull these teams together, get them to work together, and get a managing body in place so that we can start jumping this chasm and building this bridge.
Okay, thanks.
Okay?
Hi, good day. My name's Richard from South Africa. I've just got a simple question. What would it happen if the inventors of a lot of these products just made their invention open source?
That's a good idea. That's a really good question. How does the inventor, get remunerated? There are a couple good proposals out there. Here's the one we have on our website. We propose a design fee to the inventor, a reasonable design fee. Also, he gets to keep all his intellectual property unless there are significant improvements made in manufacturing, in which case he's going to have partners in those intellectual property deals. But then he gets a royalty on every single piece that's made from that technology. As I said, when the inventor starts getting $10,000 a month checks, he's going to be pretty happy. I think that there's a lot of paranoia in this business. There's a lot of public domain technology that's being hawked in the business. Intellectual property is a difficult thing to control these days, even if you do get a patent. Then you got to file a PCT. Anybody know what a PCT is? In the U.S., they cost about $10,000 a piece. Who's got 10 grand laying around to file a PCT to get your idea out there in the international market? And once you do get it out there in the international market, if somebody's thought of it already in Taiwan or Ireland or Europe or India, you're going to get sued. You're going to lose your idea. So there has to be a way to overcome this idea on intellectual property.
The current backlog through the U.S. Patent and Trademark Office is about 4 to 5 years.
Yeah.
Time of application to
Right.
being issued. That's for a mundane technology, much less something that might have new frontier science principles in it that would require more examination.
Right. So he's talking about the amount of time it takes for patents to go through, for the examiners to look at it, decide whether it's patentable or not patentable, and whether there are any infringements on that idea. But if that technology goes into production, nobody can patent it. It's just in production. You're making fridges, you're making trucks, you're making cell phones, you're making computer with batteries that never run out. You're in production, you're making money. And you just keep going with the technology. Do we have really time to sit around as a society and quibble about this 4 or 5 year who owns the idea? Who really owns the idea? Where do the ideas come from? I mean, yeah, they're pouring over everybody, over all ages.
So that raises another point, that you don't own yourself with respect, if you have a birth certificate, you're owned by the corporate government that owns you. So it does, law and jurisdiction thereof becomes a seminal subject which actually needs to be explored by everyone and understood. Because that's how we're being subverted from the moment of our birth.
Yeah, he brings up a really good point too. If you accept the money from the same source that the NERC accepts their source from, it comes with a lot of strings attached. And they're sticky strings. And they're going to want to know how the money's spent, who's it going to, what ideas are you coming up with, who you're competing against. All of that's going to come with it. Maybe $1 billion could be raised on the private side globally. Right. Right, but investors want to see a return on investment. They want to see an internal rate of return.
Return on investment is the discipline that makes sure you're investing in something that
We're not past the concept stage yet. We can't even make those models. The pro formas are worthless. We've got to jump the concept stage to prototype stage. Sterling, how many technologies are stuck right before the prototype stage?
Well, I would break it down into even more steps between. We just posted a document last week, idea to market, the steps that are involved. There are about 20.
20.
Yeah, and everything from engineering to testing, getting the fundings. There's stage 1 funding, there's pre-funding where you're just getting your friends and whatnot. There's stage 1 funding, there's stage 2 funding, those are steps. You've got to write your business plan. There are like 20 steps from idea to market, and the technologies are at various phases within that range. And the whole idea of the New Energy Systems Trust, which is along the lines of what you're talking about, is to facilitate that incubation process to help these guys move down that path and to understand that there is a path.
Yeah.
Like you made a very good point, it's not like you just come up with a technology and then you hit the copy button and it's out in the market.
Right. Right. It takes a lot of development to get there. In the meantime, daddy's got to eat every day. So this overhead keeps going on. I think we're out of time now, but the point is that we can make a business case for these breakthrough energy technologies. I think I got one more question here. You got your hand up right there.
Yeah, my question was more or less answered by what you said. I mean, I share your vision for that, but I think isn't it kind of optimistic to take funding from the same organization, as you said, that wants to centralize it and think that they will accept a project from the same funding to go exactly the opposite way? So it must be private funding and go the other way.
Yes, I do think that. I absolutely think that, because the whole idea of centralizing the grid and controlling the grid, they already realize what the threat is. They already realize they're doing a really poor job of the deliverables, which is being able to preserve that grid and deliver us power. They realize that the end user needs a safety net, and they don't have it. They do not have it. We're not proposing spinning the meters backwards and taking their ability to earn revenue away from them.
But that is automatic the outcome. I mean, once this decentralized thing is set up, of course they also know that it doesn't take much more time after that they are not needed.
It takes a lot of time. We'll be 25 years.
You won't need linear distribution of energy much.
I disagree. I think we'll be 25 to 50 years before we even scratch the surface. They will never feel it. But those dark areas that you saw there in New York City might go away. If the lights go out, we need to have a way to not be cave people again, which we would be without electricity. It wouldn't be long. These buildings, these cities, these houses would get very cold. We'd be starting to look for things to burn to stay warm. And if you have been to China lately, you see what happens to an entire continent when everybody goes and gets and burns what they can to stay warm. There are no trees in China. They import lumber for a reason. 5,000 years of no energy.
Are you up for 15 minutes more questions?
15 minutes, yes, I'm up for it. Bring them on.
I just want to ride on the coattail of that guy.
Okay.
You see, there's like this thing in Aikido, you could use other people's force against them. And here's the other thing, and I do want to address your concern, okay? So later on, Catherine's going to be talking about economics, okay? And that's the area that's very interesting. It's about whether after we make this money from this energy system, what kind of currency or what kind of, that we actually want to invest this into. So we could invest into a system that's currently is rigged. You know, the Federal Reserve can print as much money, dollar as they want, and that's the reserve currency because I'm not going to go into that. But there are other alternative currency in this world right now. A lot of them work on local level. And what I'm recommending is, after the money has been made in this, part of that be invested into an alternative currency. We can talk about that later, whether it be Bitcoin or Ithaca hours and stuff. And this is, I think, is the beginning of real transformation.
Well, you're talking about a complete systemic transformation, and I respect that, I do. But here's what's going to happen. In my industry, the automotive industry, when we started out, you could mash the motor, and you could do a 12-second quarter mile, and you could buy a car like that for about $3,000. What kind of mileage do we get? Who cares? Gas was 29 cents a gallon. So gas usage in the United States has been flat for 25 years, even though we have a lot more cars on the road. We get more and more efficient with our vehicles, partly because of regulation and partly because the public demands it. That's why there are no small trucks for sale in the United States, because the CAFE standards are now 26 mpg. No small truck can do 26 mpg, so they make mid-sized trucks because they're allowed to get 17 mpg. The point is they're selling less gasoline per car, but they're making the same amount of money because they raised the price. If they're selling less kilowatt hours through your meter, it's not going to hurt their revenue one bit. They're just going to raise it from 6 cents a mil to 7 cents a mil. They'll make exactly the same amount of money. We won't impact their economic model at all. What we do is protect the other side of the grid with a decentralized, low-voltage supply of electricity to homes and businesses. Yes, back there.
Yeah, I wonder if you measure the amount, the level of electromagnetic fields in your car. The reason I'm asking is because I know quite a number of people who get sick from sitting in electric cars. And also if you look at the research of Dr. Klinghardt, Dr. Mercola, it seems that the human being isn't really adapted to strong magnetic fields, especially given the heavy metal pollution and the Borrelia, Lyme borreliosis that everybody has and so forth.
It's a good observation. He's talking about the electromagnetic frequency effect of passengers of electric vehicles. You're absolutely correct, and I'm not going to answer that question in this meeting because it's key to the technology of how our vehicles work, okay? Because I don't want to reveal that in this meeting. But trust me when I say there's a big difference between vehicles that run on AC and vehicles that run on DC. Yes.
Can I jump in here real quick?
Yeah.
I'm from the U.S., California, working with Joel Garbin and Sterling Allen at the New Energy Movement. One of the reasons why we're here is to form a partnership with the Holland Group. And we are a charitable organization. And so you see a recurring theme right now of how do we pool funds up for these inventors to tap into.
Yeah.
So that's incredible. And one of the methods that we're talking about, and you're hitting on it, and you're using the word charity, and the model that we're talking about here, we've been having some late night meetings, is to really tap into the grassroots. There's a lot of people that this is all resonating with at the very grassroots level, advocate level, where people just want to see a breakthrough energy. They're not necessarily inventors, they're just sympathetic.
Sure.
And so we're talking about hitting cities around the world with these projects, if they qualify, to bring those to the public as a portfolio of projects and having people open up their wallets $5, $10, $100 at a time and provide a tax-deductible donation to that fund. And so we can go after some very public dollars in the billions, but we can also go after the ones, $5s, $10s, $100 at a time in cities around the world not only grabbing the money, but actually getting their attention to the movement, getting them behind these projects in their hearts and their wallets, and they watch these projects as they develop. And so that's the type of structure that we're
Todd's
talking
right.
about.
I mean, there is a structure for a 501c3. I'm not an expert at doing that. We do have experts in the room that are good at doing that. It's a tricky minefield because you can't lobby when you do this. When you get a 501c3, you can have that pulled, your tax-free status pulled in about 90 seconds if you go to Washington and talk to the wrong people. Robin and I have been and spoke to many, many congressmen. We've been to business summits in Washington where we spoke to more than a dozen Congress people at one time. They are powerless to help us. The agencies, departments, bureaus, and administrations in Washington control everything. What I'm saying is there's a way now, because there's an opening with this NERC, to piggyback on that system because they just had their butts kicked last week in New Jersey. And they're smarting a lot right now. They're vulnerable. We could piggyback in there and say, okay, take 99.5% of the money that you're going to use to centralize and control this grid. Give us 0.5% and let us cover the backside.
Brooks, it'll be blocked. With respect, in 2010, I was Director General at the United Nations for Renewable Energy, and I used that station, that office, to approach the Gulf states in point of fact, and we raised $5 billion ostensibly. That was what I asked each of the GCC nations to contribute to a global energy fund. And we invited them to the table in a head of state summit, energy ministers, finance ministers, and the point I was trying to make, the argument to what I call the Texas Mafia and the Gulf Mafia, the same mafia, backed by European central banking cartels. And the point I was trying to make to them was either way the planet is transitioning to a new energy economy. Now you, excuse my French, sons of bitches can be involved in that transition. Now, and if you're smart, your smart money will be involved in that transition. And
how did they respond
to that? Well, they agreed to it. Like I said, ostensibly we raised the money. I convened a summit for heads of state 72 hours before that summit was due to take place. Some background shenanigans took place at high office, and we had the red carpet pulled. My organization, which was sponsoring, for the first time in history, an NGO was sponsoring a summit of heads of state, energy ministers, and finance ministers. We were left with a huge omelet landing on our heads by design. And I was the Director General for the Intergovernmental Renewable Energy Organization. I had the diplomatic clout to do this. But the powers that be, the central banking cartels and the Babylonian priesthood, as I would continue to refer to them as, they were sitting to the side, waiting for my organization and the Office of the Intergovernmental Renewable Energy Organization to construe this summit. At the optimum moment, boom, they pulled it out. I had warrants out for me. I mean, you know, they tried everything in the book to hobble us. We managed to launch the initiative nonetheless at the Millennium Plaza at the United Nations. And we did launch it, and we did in fact launch the fund, the concept of the fund, but the money disappeared. But we discovered after the fact that Goldman Sachs, and I'm happy to say it openly, hand in glove with the World Bank, were behind this. So you've got some real big problems when you're trying to aggregate big funding. You have a right as citizens to go and lobby your government, but that's all it's going to be. It's going to be a lobbying tactic.
Yeah, I hear what you're saying.
Bitcoin and crowdsourcing is arguably the only way left to engender a substantial amount of funding to hit this, and to hit this behemoth right between the eyes. But I would also suggest that we've got a very narrow window to do that because of what Mr. Obama and his cronies are about to introduce as draft legislation to outlaw the capacity of using the web in this way. So we've got a narrow window in my
Yeah, I agree with that. The crowdfunding as a method is already being looked at as the SEC. What they're doing now, by the way, in case you're thinking of doing this, companies or individuals that do crowdfunding are now going to have to report their Social Security numbers or taxpayer ID numbers, and then they're going to check those Social Security numbers and tax ID numbers with people that are doing 504, 506, and 502 public offerings or private offerings that are Reg D companies. If you're doing both, you're going to be arrested. 506. These are Regulation D offerings that you can make to raise money. The Reg Ds are filed within a certain period of time or when you raise your money, either before or after. Depends on the state, the blue sky laws in each state, but the SEC, whether it's a public offering or a private offering, has a lot of regulations covering this. To date, they haven't been looking at the crowdfunding people. And some people have raised a substantial amount of capital for different things, way more than they went after. Now, I will say 99.5% of the companies that try crowdfunding never raise a thing because they don't have the email network to get it started. But 0.5% of them are making some serious capital. And likewise, because of that, they're starting to see some startups hit the market that otherwise would have a better chance of winning the lottery of getting money. And the SEC is going to try and regulate that. That legislation's not in place yet, but it's coming.
I raise money all the time in the UK. I'm a financial advisor and I set up funds for various different things. Interestingly, before I came out here, in a totally different meeting to this, I was chatting to some venture capitalists who were well aware of LE&R. It's the first time I've heard it raised when I haven't raised it. But we do solar energy and stuff like that. Actually, it's not that difficult. There are loads of hoops to jump through and loads of legislative hoops to jump through. But you can get tax relief in the UK, you can do it through pensions in the UK, you can use private funds. But what you've got to stop doing, and you made this point, Bruce, is you have to stop having this free energy breakthrough whole kind of big idea, and you have to focus it onto a business idea that and pull alongside and speak the same language as those business people to raise the money. And ultimately that money, because any money I set up funds for and I raise, you know, I've got to pay the people back and I've got to give them a return. It has to be profitable. It has to be a real thing. But to raise 100 million, to get 100 million or a 1 billion fund together, if everyone here really focused about how they wanted to do it and pulled all their contacts in, it's not difficult, yeah? I mean, it really is not that difficult. That is not a lot of money.
No,
in
it's not a
terms
lot
of
of
the
money,
money out
but,
there. But it's really about doing it in a way, you know, you're not trying to fight the system. There is a system there, and if you try and fight the system, you will never beat the system. What you've got to do is pull alongside the system and work out how to do it in a way the system allows you to do it. And I'm willing to get involved in that.
It sounds good.
I'm interested in this. Yeah, it's easy. I do it all the time. Yeah. None of you are talking with those guys. None of you you're right.
I think we have a better chance of winning the lottery, honestly.
But you can do it from private money. You can set up your own funds. But they're all FSA authorised, all regulated, venture capital, EIS, super simple, not too expensive. Even authorised unit trusts, they only cost about 25, 30 grand to set up. And you can then take pension fund money in. For example, you know, I'm an expert in the UK, so I can tell you how to do it in the UK. Provided you have somewhere decent to put that money to, then you can quite easily take the money in. And in fact, I'm setting a fund up now that could very, very easily have a sub-fund that put money to this kind of stuff. Completely simply. No, Goldman Sachs, the government, no one's going to stop you. Yeah?
Well, when you get into figures above $100 million, I can tell you, my own organisation...
Yeah. Yeah, but you're going to the guys who control the system. I'm going to the small guys at the bottom who... Yeah?
I'm just... My case is that it needs to be done on behalf of the human race. So I don't know how to do it. I'm just making the proposal that it needs to be done. I made a business case for this with just a couple of simple products, a truck and a refrigerator. There's a gazillion other products that could be introduced. What we need to do is begin speaking to our respective countries and investors in those countries, even individuals in the country. When they ask for return on investment, say there isn't any. You are throwing your money up a horse's rear. But this needs to be done.
I think
the governments of our planet are taking money out of our paycheck every single day, and I'm sure they do everything we want them to do with it.
Yeah.
We need to, as a global society, take a small amount of our income and give it to a different fund that will do what we want them to do with it. We're out of time.
I think that's a positive note to end.